We were looking, well, no. F prime of A. 2. Right? No, it was 4, wasn't it? No. Okay, I'm sorry. I only got 6 hours of sleep last night. I was shooting for more, but it didn't happen. All right, F prime, and we are recording now. F prime at 4, not at 4, but at 2 is 4, right? So that implies that the inverse derivative. And here's the thing, you're going to have problems where, and the reason I'm trying to make you so sure that you are clear on this is that you're going to have problems where they don't even tell you what the function is. They just tell you if f of 3 is 7 and f prime of 3 is 12, what is the derivative of the inverse when x equals 7? So you've got to be able to put all that back together and work backwards here. So the inverse derivative equals 1 over 4, right? So it should be 1 over f prime of a, and I just want to make sure we had that right, because for some reason I started thinking we said b, and I was like, no. But this would be at what point?
At inverse.
Well, since we're doing this specific example, that was at 4-2, right? So in terms of the AB language, if AB is on the original point, the related point is BA. Got it. Everybody with me now? Okay. Did anyone get any problems done? Did you try?
I tried.
Okay, grab your derivative sheets because we're not going to take the time to write these derivatives out. This book basically has you discover them by inverting the functions and going through all this stuff. And rather than do that, we're just going to use them as rules and run with it. The first couple years that I taught the class, I actually tried to do it the way the book did it, and people were like, you know in the cartoons where you see like somebody's eyes getting like really big and it's like there's little stars going around it like they just got punched in the face kind of thing? That's kind of the way my students look, so I quit trying to do that and accepted the reality of where we are. So what we're going to do now is we're going to look at examples, which is the only thing we didn't get to yesterday other than the finishing of that little conversation we were having that felt so rushed. So we're going to start with number 2, which is y equals the inverse cosine of 1 over x. Now, I used to not say things like this because I was afraid I would plant the seed of incorrect information in the minds of people for whom it did not already exist. But I feel like I need to, because one of the things I'm seeing as I look at y'all's quizzes and stuff is that your trig is still weak. All right? This is not, what we just wrote is not the reciprocal of cosine. Get that straight. This is not the reciprocal. This is the inverse cosine, okay? Which you may also see written as arc cosine 1 over x. And when I was a student, I always thought that's dumb. Why do we have 2 different notations for it? Why would we ever use the arc version of it? And I've started to understand as a teacher that it's more explicitly not the reciprocal of cosine when you write it with that arc. Okay, there's nothing in your brain that says, oh, well, that would just be 1 over cosine. No. Neither is the negative. They both mean the same thing. Got it? All right, so we want the derivative. So we go to our reference there. And what is the derivative of inverse cosine? So it's going to be -1 over Why are you so confused?
Oh, we're looking at this.
Yes. That's why I said. Okay, maybe Clark later. Maybe you should save a space in your work in your notes there to actually write these in your notes if that's what you need to do. Okay, but that's what we're doing.
Okay.
Everybody with me now? Because Clark was staring at this sheet, confused, like what is happening, and so then I was confused about the fact that she was confused. All right, so it's the square root of. No. Look at the left side of that. What was inside the inverse cosine?
1 over x.
Yes. So we have to have 1 over x squared. Why? Because I have a composite inverse trig function, don't I? How do I know it's a composite? Because it's not just x inside. What does this sheet tell me? when it's just x inside. Yes? Okay. So what have we just done by writing this much? We've taken the derivative of the...
Outside.
Yes! Thank you, Mackie. The outside part. What is the inside part? So I have to multiply by...
Don't get.
Oh, dear God, no.
Square root of 1 minus.
Whatever
No,
x.
it's negative.
Woosah. Okay, let's rewind. How do we know that the very first thing we wrote, which was the problem itself, because y'all wrote, I won't say eloquently, but generally you all started it off with some variation of saying that if you're going to take the derivative of something, the first step is to decide what it is. What is this animal? And I was really happy to see my own question coming back at me like on 18 different, not really 18, it's probably like 8 papers that you wrote for me. So what kind of animal is this? It's a composite. How do we know it's a composite? Because it's not just x inside the inverse cosine. It's 1 over x, right? So this is an f of g of x. My g of x is 1 over x. Please don't tell me the derivative of 1 over x is 1 over x, because it's not. So how should I think about 1 over x? And I'm going to come over here and do it over here in the corner. I got 1 over x, which is equal to
1.
x to the negative 1. X to the negative 1. 1 over x is equal to x to the negative 1. Yes? And if you don't need to write that, you at least need to think it to get the right derivative. Because then it becomes obvious that I'm going to multiply by what? Negative x to the negative 2.
Wait, but I thought
We got to do
we
the
deleted the
inside
inside.
the same.
The inside is
We did leave the inside the same in the outside derivative, didn't we?
Yes.
And then you multiply by the derivative of the outside. I'm sorry, the inside. Yes? It's weird because I think I anticipate what y'all are going to get confused about, and then I don't. All right, so obviously we are not leaving this as our final answer. Okay?
Put your
In fact, let's come over here and rewrite the second thing. In fact, I'm gonna leave the denominator off of that first piece, and let's just rewrite negative x to the negative 2 as a fraction. What should it be? In fact, can we go ahead and deal with the signs? What's going to happen? I now have a positive 1 on top because it's a negative times a negative, yes? So we've gotten the negative out of our hair. So what do I write right here? 1 over x squared. That's the easy part.
what is that?
Wouldn't it be the square root?
Oh my God, no.
Wait, oh wait, no, never mind, never mind.
I'll tell you what, even in my exhaustion, I'm going to reserve speaking for 7 seconds after every question. How about that? Because y'all are actually, the filter's not working today, so it's just coming out.
The way that you said that.
No, that's what goes through my head all the time. That's why sometimes I just laugh and won't tell you what I just thought. I mean, because sometimes it's the X-rated version, and I'm not going to say that to a whole group of kids. Okay, so now the other problem is that I have this hideous thing at the beginning that is a fraction, and in the denominator of the fraction, I have another fraction. Not okay. That's really bad manners to leave that. And I will have equally bad manners when I grade it.
I don't know where you just got that.
You don't know where we got what?
That last part you just.
Okay. Where did the negative go? I canceled these two negatives to make that positive, right? What is x to the negative 2? What does the negative exponent tell you to do? Put it in the bottom. Put it in the bottom. So we did. And when we put it in the bottom, it's happy. It's no longer negative.
Okay.
Okay? Good? Yes? Everybody know? Can we go to the actually hard part? Not really actually hard, but actually you will think it's hard. We have to get rid of the fraction on the bottom. Okay. Well, let's look closely, and we're going to slide over here to the side maybe to look at this. We have 1 minus 1 over x, the quantity squared, right? Which is really equal to, we'll draw a line there to make sure that's clear, 1 minus what?
1 over x squared.
1 over x squared. So far so good? But I can't have that either because that's still a fraction, right? So I've at least got rid of the parentheses and the square. Yes?
Yes.
Okay. So what do I do to get rid of a fraction? Just in general. Multiply by its reciprocal. Okay? Well, and this is the part that makes it tricky. Because what we're going to do is we're going to do just that. But we're going to multiply inside the square root by x squared. So I have 1 minus 1 over x squared in parentheses being multiplied by x squared. But now let me ask you a question. Is it ever okay to multiply just the denominator of a fraction by something? No. So how do we fix that?
Gotta do it at the top.
We multiply the top. Well, if we look at the top of this, we have a 1 sitting up there, but we just multiplied by an x squared inside a square root, and I'm going to ask you to pause before you answer this. What does that give me?
No, it's the is it absolute value of x?
Okay, now I can speak. No, it's not. It is the absolute value of x. Yes. It is the absolute value of x. So we're going to multiply the top by the absolute value of x.
I understand what you're saying, but why did you put absolute?
Teach me how to inverse derivative. Teach me how to inverse derivative.
That is going